I arrived at MIT in the fall of 1990, midway through the final year of Project Athena. With vision and determination, Professor Gerald Wilson, then Dean of Engineering, together with President Paul Gray and Provost John Deutsch, had led this remarkable effort to create a new educational computing environment at MIT. Directed first by Professor Stephen Lehrman and then by Professor Earl Merman, the project challenged the entire MIT community. Through the efforts of the faculty, students, and Athena staff, the project has succeeded in creating a system that is transforming the ways in which we approach computing, learning, and information sharing. Through Project Athena, MIT is providing leadership in the use of information technology to enhance education. At the moment, the Athena environment at MIT is the largest distributed, truly interoperable, yet heterogeneous computing environment on any campus in the world. This model is being adopted by a variety of universities, both nationally and internationally. Made possible by the partnership with Digital Equipment Corporation and the IBM Corporation, Project Athena has been a model of university-industry collaboration. Working side by side, people from the three organizations created a client-server software technology, including the X-Windows system, Kerberos, and many other system and application level programs. All of this was made available to the outside world. Now the Athena computing environment is playing an influential role in industry. Over its 8-year lifetime, Project Athena drew together a unique and talented group of people working to bring all of this to bear, at a time when the vision of large-scale educational computing was evolving and shifting as it grew. You, the Project Athena staff, have given much of yourselves, your visions, your labors, your creative energies. You have much to be proud of in Athena's accomplishments. On behalf of MIT, I thank you and I salute you.
Anne Levin uses Zephyr, an instantaneous messaging system, to broadcast a question over the Athena network of over 1,300 workstations.
During the Civil War, who gave the opening speech before Lincoln delivered the Gettysburg Address?
Immediately, the message pops up on workstation screens across the network. Those receiving the message subscribe to a channel called White Magic. It's like tuning into a Citizens Band radio channel to hear what is going on. If you're not tuned in, you miss the message. The question sparks 20 students to chat about the Civil War over the network. They decide to create a new channel called Civil War and continue their discussion. Anne can send and receive a Zephyrgram from any Athena workstation. She doesn't have to know where or even who an individual is on the network. Zephyr will instantaneously deliver the message to anyone who is subscribing from an Athena system anywhere in the network. In 1 year, users exchange millions of Zephyrgrams.
Zephyr is used also for distributed maintenance. We don't have a central operations control room because the day-to-day operations maintenance staff can communicate immediately and selectively with Zephyr anywhere on the network. For example, if a file server begins to fail, it will log the errors and also send a Zephyrgram to alert the staff. If, for any reason, we need to take a central service offline on short notice, Zephyr provides us the means to instantaneously notify all the active users of the particular service without sending a broadcast to everyone on the network.
Zephyr is also integrated into our online consulting system. This system connects users and consultants who may be located anywhere on the network and tracks the progress of all unanswered questions until they're resolved. The online consulting system makes use of Zephyr to tell users and consultants they've been connected and that new messages have been sent. Consultants use Zephyr to conference among themselves and with operations and telecommunications personnel. Our consulting staff of 9 full-time equivalent consultants plus volunteers currently answers 2,500 questions a month, a rate which far exceeds those for questions handled in person or over the telephone.
In 1983, MIT launched Project Athena, an experiment supported by the Digital Equipment Corporation and the IBM Corporation to explore the educational use of a vast network of computer workstations. Today, 10,000 students and faculty can log in at any workstation located in 40 clusters, 150 offices, and 5 living groups. Athena also reaches into 2 lecture halls and an electronic classroom. This highly distributed yet centrally managed network required a distributed system design far more advanced than any previously available. One requirement was a completely rethought and redesigned authentication system. For example, when Zephyr sends a message, it verifies that the sender is authentic, in other words, a legitimate Athena user, so the recipient can be certain the sender is who he claims to be. The authentication process for all distributed computing services begins at login, when the user's name is sent by the workstation login task to Kerberos, the authentication server.
The Kerberos server provides communication security for every host, user, and service on the network. To authenticate a user, it seals an encrypted ticket in an envelope that can only be opened by the intended recipient. That envelope is opened by the password at the workstation, and this encrypted ticket allows IDA to ask for more tickets that allow access to other network services. With this scheme, no clear text password is stored or goes over the network. The authentication process is secure and provably secure from network eavesdroppers. Even if the ticket is copied by an illegitimate user, as it crosses the network, it can't be used to gain access to protected services. Each of these tickets has a containment lifetime, which helps to protect the integrity of IDA's data. Now IDA would like to edit a report. From a text editing window, she'll call up the file that contains that report.
At login, IDA's ticket went back to Kerberos to ask for another ticket to gain access to the file server, which has stored her file.
IDA's file isn't stored locally on the workstation she's using. It's stored on one of many Athena file servers, and in fact, it might be on a disk all the way across campus. But IDA doesn't have to know which file server the file is on. The Athena Hesiod service keeps track of that, along with lots of other important information associated with files, users, workstations, and other components of the Athena environment. For example, when IDA logs in, the login program on her workstation communicates with a Hesiod server to find where her personal files are stored so she can access them. Login makes IDA's remotely stored files seem attached to the local workstation. At Athena, we currently support 3 different types of file systems: NFS, or Sun's Network File System, which we've enhanced with some Kerberos security features at the server end; AFS, which is TransArc's Andrew file system; and RVD, which is the MIT-designed remote virtual disk.
The X window system allows IDA to simultaneously open windows for other applications and network services such as mail. In combination with the Unix operating system, the X window system is the vital service that allows data to be displayed uniformly, regardless of the make of workstation connected to the network.
At the heart of many educational applications of computing is the use of visualization to help understand and illuminate difficult concepts. But visualization calls for programming of a display, and historically, that display programming has presented the application designer with a hard problem. Each display is programmed differently, so you can't write one program that runs on several different manufacturers' computers. Even worse, most manufacturers have several different displays of their own, so one program often won't run on more than one product of one manufacturer. The result is that if you want to use visualization, you have to plan to rewrite the display part of your application once for every different display device on the campus. In addition, each year, manufacturers announce new display devices, so you have a job that goes on and on. This need for extensive and continued commitment to display programming has really inhibited people who have good ideas they would like to try. To deal with this problem, Project Athena, together with the MIT Laboratory for Computer Science, undertook the development of a new standard programming interface for display devices, and the demonstration of this new interface on several different displays made by its two sponsors, IBM and Digital Equipment Corporation. The new standard display interface is called the X window system. People who write visualization applications have found that this development has been astonishingly successful in two ways. For the first time, a long-held dream has been realized. One can write a program in the environment of a digital workstation and expect to move that program to an IBM workstation without reprogramming. Our students see the benefit of this success every day when they do their homework using different kinds of workstations interchangeably. The second success is that the workstation manufacturing community has embraced this new standard so swiftly that virtually every engineering workstation made anywhere in the world now provides, as part of the manufacturer's operating system, the X window system standard. We're beginning to see the benefit of this second success in the form of applications written elsewhere that can be imported and used at MIT with very little effort.
When Ida opened the mail window and looked for new mail, the ticket authentication routine executed again. Now Ida can send and receive mail.
All mail messages sent to or from any Athena user are cleared through a hub, and from there are dispatched to a post office server. Ida can pick up her mail from the post office and move it to her personal files. She doesn't need to know which post office holds her mail. The mail reading software locates her mailbox using the Hesiod name service.
The mail system is another example of the Athena distributed system model. Control and configuration of the mail system and other services such as Hesiod and Zephyr reside with the Moira server. Moira is the central database that contains the data about files, users, hosts, services, and mailing lists. It is the authoritative master source of the configuration information for servers on the system. From Moira, a small staff can manage Athena to meet the day-to-day demands of the users. Like all the other servers, it is dedicated to only one function, which is a key operating decision for maintaining a robust system. In addition, all parts of the network are configured such that no single point failure of the network can result in a service outage.
The Athena distributed system model influences the way workstations are configured. Each workstation has only the minimum components of the operating system needed to connect to the network. A workstation holds no data. All personal files and the rest of the operating system are on the network. Each workstation is alike and available to any authorized user. So the installation of a new workstation is just a matter of inserting a floppy disk that has a bootable operating system. The floppy holds an installation procedure that copies the minimum components onto the local hard disk. Likewise, if there's a problem with the workstation, one reloads the components and reboots. If it doesn't reboot, it's probably a hardware problem. Because of the ease of installation and maintenance, we can support thousands of workstations with a small number of staff. This great labor saving comes from 2 points. The first is that dataless workstations need no direct management whatsoever. And the second is that since there's only one procedure used to install, repair, or update a workstation, almost no one is without the skills required to maintain his or her workstation.
In addition to the public workstations, workstations solely for private use can also be accommodated on the network. Private users can store applications and files on their own workstations or on the network, and can even provide services to the network. They can have their own peripherals, like a CD reader, and still have access to network services. Of course, access to network services from a private workstation is still authenticated by Kerberos, even if the user chooses to do their own system management.
The backbone of the network is a fiber optic token ring with routers supporting dozens of Ethernet subnets using TCP/IP. Workstations, central services, file servers, print servers, remote sites like Woods Hole Oceanographic Institute 80 miles away, and other computers like a Cray 2 and IBM 3090s are on the subnets. With this layout, the network and other subnets will still function even if a server fails. Project Athena demonstrates a system design that can scale to accommodate the addition of thousands of workstations and users and still be manageable. It has enabled students and faculty to learn and communicate in ways never before possible. The Athena computing environment has been influential to industry as well. The X window system is an industry standard, and the Kerberos authentication system is well on its way. The ideas of central management, notification, location-independent computing environments, and predictive maintenance are all taking hold wherever there are large distributed computing requirements. Project Athena is a model for the future of distributed computing.
J'espère devenir journaliste.
Après la pause, Denis Talbot nous parle des chantiers de la bombe dans le cadre du Rock Flash.
On some Athena workstations, windows on the screen open to a multimedia world. Student Masood Nabi watches Canadian TV in the X video window, types a paper in the Emacs window, and talks to friends around the world in the IRC window. IRC stands for Internet Relay Chat, a spontaneous electronic messaging system connecting Japan, Norway, Finland, Sweden, Germany, New Zealand, and Australia.
Finland is actually quite an interesting place. The people over there to tell you different things about their country, and you can tell them about the things over here in Boston. I have quite a few friends in Australia also through IRC. It is really very enjoyable and I like it very much.
Il se lance une carrière solo. Également, on aura Crash Vegas.
In Douglas Morgenstern's Spanish language class, students use an interactive video disc to see the cities and landmarks of Colombia and hear Spanish spoken in daily life.
Buenas tardes. ¿Tú lo conoces a él?
This is more of an interaction with the culture, and I think that's learning the culture is a big part of learning the language. It's a big aspect of it.
Iba mucho a Boyacá a pasear con mis papás. A ellos les gustaba llevarme a que admirar el campo.
Workstation windows open to worlds beyond our planet. Students in Professor Richard Binzel's course on optical astronomy probe planetary images at Athena workstations. Workstations provide the computational power necessary to run the same image processing software that is used by professional astronomers around the world. Linda Souter, who photographed planets at Lowell Observatory in Arizona, keeps in touch with researchers there over the network.
Sometimes there's weird things that I see on the log or, in the image itself, and I don't understand how to explain it, and so I can just call up a window and write to them some email, and, a couple hours later I get a response.
In 1983, MIT launched Project Athena, an experiment supported by Digital Equipment Corporation and the IBM Corporation to explore the educational use of a vast network of computer workstations. After 7 years of intense ongoing courseware and system development, more than 1,100 workstations are spread over a campus-wide network. 10,000 students and faculty can log in at any workstation located in 40 clusters, 150 offices, and 5 living groups. Athena also reaches into 2 lecture halls and an electronic classroom. The electronic classroom has changed forever the way Ed Barrett teaches writing.
We had one 10-minute exercise. I asked students to write for that amount of time. Each sentence had to begin with the phrase, "I like to." And one student came up with, "I like listening to music, I like laying on my bed, not doing anything when I know that I should be doing something. I like doing things a little different from other people." But later on in the passage, he goes on to write, "That's why dogs and wolves howl late at night. It's like those ancient Gregorian chants. That howling is the dog's way of showing worship, or a wolf pack's delight."
He gives you some strange topic at first and says, "Write for the next 10 minutes on this." And that also bothered me too. I thought, oh boy. The first time he gave that exercise, I sat there and stared at my screen. I didn't know what to type. But as time went on, I just let it flow. He just says, leave the errors on there. You know, don't worry about misspellings or anything like that. Just do it.
It helps you get over that writing block that I normally get when I just sit down and go, okay, what I'm going to write about. When you're forced to do it, and then you talk about it afterwards, which helps you say, well, maybe I can approach this differently next time.
The hardware seems to melt away in the classroom as it gives us an opportunity to see the students writing. So our focus is really on the writing, on the students' work, and not the network, not the software or the hardware. So it really becomes a kind of open window to see what other people are doing and to share it with others and to talk about it. That's how writing is done in the real world. Now it can be done that way in the classroom.
When you have this group of people who are criticizing or supporting your work, then you get better, and you take a different stance when you start to write, when you know that everyone is going to be reading it.
In other writing classes, what happens is I'll probably write a draft, see the professor maybe once and then turn it in. But this way, when I turn it in, Professor Barrett would often send stuff back to me. It really helps because this happens during the process of writing. There's better communication through the network.
You log on at 10:30 at night and you see, well, oh yeah, he sent my paper back and he has these comments and you can respond to them.
Several of the students were working on projects and discovered that they could send me mail and say, hey, this and this isn't working, what's going on? And I would fire back a mail message, sometimes within an hour, sometimes just within a few minutes if I happened to be working on the system, but certainly by the next morning. And so there was sort of this interaction which helped them over stumbling blocks, wherever they were. They could be working in their living group or some other part of the campus. And so I felt like, and they felt like we were working together on these things.
Professor Tom Weiss and his students were working on a project to understand the behavior of electrically excitable cells based on a computer simulation of the Hodgkin-Huxley model. Leslie Fan used the power of the Athena workstations to run through hundreds of simulations and analyze the plotted results.
I couldn't look at a bunch of equations and just say, well, obviously the refractory period will increase or decrease. And just because there are so many of them and they're totally interdependent and it's just like millions of feedback loops and just a mess. So, I mean, for this, to be able to just alter the temperature and see what happens is amazing.
The model is subtle and complicated for junior level students to understand. And the software makes it approachable at an intuitive level. They can then go back to the equations and breathe life into them and see what they mean.
Professor Weiss found that contrary to expectations that Athena would isolate students from faculty, the network fosters more communication with students.
Leslie, for example, in course of discussing her proposal, came into this office several times to sort of formulate that proposal as tightly as she could. And that's what they typically do. And when you work with them in an electronic classroom, you're really interacting. I really get to know the students more than I did years ago when I just showed up in the lecture room and talked. I get concepts across more clearly. I also think I'm doing a better job of teaching the students how to think.
Computer simulations by no means exclude laboratory experiments. In Professor Will Durfee's class on designing smart machines, students are first required to design a control system that works. Once they know the real behavior of the system, they simulate it at an Athena workstation. Graduate student Michael Goldfarb can easily test different parameters, gain an intuitive feel for how the system behaves, and compare simulation to reality.
Connecting the simulations on Athena with reality is another major step, another major gap that needs to be bridged. And a lab like this bridges all three, the theory from class with the reality here and the simulations on Athena with the reality here. And so it's a very good lab as far as making or letting you see the whole picture, which is very important.
Project Athena gives students a chance to put into practice what they learn in the classroom. Many Athena courseware and system software applications are written or supported by students.
I talk to people
who use zip and EZ, and they tell me, well, you know, this is kind of nice, but I really hated this part. And you're thinking to yourself, well, I sort of like that part. And they're telling you that it was a piece of garbage, so you've got to go back and change it. So it's just a practical experience of being able to produce something for other people to use.
Students tie theory, reality, and simulation together when they design a wing using software developed by Professor Earl Merman. They free themselves from tedious calculations and harness the computational and graphic power of the workstations to visualize their designs.
One has to understand why a thicker wing or a thinner wing or a cambered wing or a different flap influences the airflow in such a way that gives a better design. Those principles they've been introduced to in class, but until they can apply those right in front of their eyes and see it, they can't really learn it. This way they learn it, by doing.
I turn the wing so that it's pointing straight down. Now, this isn't too often what happens, but hey, if your airplane stalls and you're in a nosedive, well, maybe that's something you need to know. So in order to really take a look at the physical aspects of it, you have the software which will perform the math for you and give you the graphical interface. You can see exactly what's going on.
The graphic power of Athena workstations also helps students untangle a web of logic, argument, and counter-argument in Professor Hayward Alker's political science class on debates and arguments. Bill Large labored over 300 hours on his senior thesis to construct a logic graph of the Lincoln-Douglas debate of 1858.
You're making them with something easy to use. Instead of having 200 pages saying, look here, look there, turn back here, turn back there, you're dividing it up by issues, you're dividing it into time, and you're making it easy to study, basically, is the whole idea behind this. The computer doesn't do any thinking for me, it just allows me to think more clearly. It's the scope which is involved here is so large. Your mind just can't comprehend how large it is, really, and be thinking about all these different things everywhere, so it's there for you on the screen.
Students in the Urban Studies and Planning Department use Athena workstations to visually synthesize and alter a myriad of diverse data. For example, they can overlay graphic representations of demographic and zoning data on an aerial photo and see how land use affects population density. Professor Joe Ferreira.
By taking away the arithmetic and the sort of tediousness of drawing maps by hand or of running through these models without the aid of the computers, that you can get people to understand more of the analytic modeling tools and free them up from the time-consuming part of that so that it's more engaged into the problem solving that they're trying to do.
As an ongoing experiment, Project Athena is ever-changing as students and faculty create new applications. The unfolding applications embody the conviction that each individual is on a unique journey to make his or her own discoveries and share them with others.
We're using software that really is designed by the people who are using it and who know best how they want to use it. And that, I think that that's probably one of the more difficult things about Athena, but it's ironically also the best thing about it. It isn't fixed, it isn't static, it's changing. It's a use of computers to make richer the interaction among human beings.
It's fun to motivate them, it's fun to see them react, and the computer's a vehicle for that. You know, if I had to, I'd stand on my head to motivate them, but it's easier for me to push buttons.